Hi, my name's Leo. I work in our corporate labs at Texas Instruments. What I'm going to show you here is just stuff that I do on the weekends, just kind of hobby stuff. So I don't work for our microcontroller group. I actually do stuff with analog sensors and wireless, Wi-Fi, which is what I'm wearing. I'll talk a little bit about Wi-Fi. But I've written a little virtual machine for microcontrollers. It's kind of like Android, but it runs on like $1 microcontrollers, so it's cool from that perspective. This is our MSP430 LaunchPad. The virtual machine runs on that. This is a board, basically, which I designed. It's open source, open hardware. It's the same processor, except it's got either a Bluetooth or Bluetooth Low Energy radio on there. It's also got our new power transistors on here. These are capable of delivering kilowatts, basically, of power. And it's got battery management on here, anywhere from 5 volts to 24 and up. So you can connect whatever voltage you want on it. This is our TIVA series LaunchPad, and it's just basically Cortex-M4 instead of MSP. And what I've got up on the screen is basically a VM that I've written, and it's written in an environment that's called Energia. And Energia is basically a Arduino-like environment, so you can take your Arduino sketches and run them in this environment. This code's all available on GitHub. So in this case, the virtual machine is connected straight via this USB port here, and I can send commands directly to it and program it. You want to set it to 100%, then if you look at the board, pin 30 is also connected to an LED. So I turn that on, and it turns on. So if I say put pin 30 / 10%, and you'll see it's going to dim it down to 10%. If I put 0 or whatever, it's going to set it to 0. So every pin is mapped on here. There's some pins that are analog input. For analog input pins, I can just say get. So get 7, for example. Oh, something's going on.
Uh-oh.
Hold on a second. Energia projects, this is the code. You can see this is basically just taking all those commands. You can see right here. If I get the get, then I set the command to 1. If I get the put command to move command, we'll do a high frequency capture. So it'll return 1024 at whatever frequency I want. And then I can do spectral analysis on it. So it's just a real fast way of getting spectral data. Or if you want to capture more data, you can do that too. So those are just some simple examples. You can do this also over wireless. You just connect any Bluetooth module to pins 3 and 4 on here and change the serial to serial 1 in the code, and you're talking over Bluetooth. And for that, then we have a different app that we've written.
What is that little controller called?
This is a TIVA LaunchPad. It's a Cortex-M4. The same environment will run wirelessly. This is a programming environment.
This is
okay. So you have all the commands basically on a single screen. And you just change the pins and the values that you want, and you can actually write code. So in this case, this platform will actually take the code, run it. So what I've got here is, all these platforms will be running the Energia environment. Will be running also this virtual machine. I've got an example of something I built, which is a microbrewery, using this, and I just connect to the microbrewery with my iPad. And once I've connected with my iPad, I should be able to turn on the pumps. So now I'm running one of the pumps. Now I'm running the other one of the pumps. The pumps are connected to pins 18 and 19. You can see right here, it's exactly the same language, right? So put 19100, turns that pump on. So turning it off. So like if I wanted to write a program, let me just hold it like this for now. But if I wanted to write a program that used the thermometer, which is connected to pin 7, so like if I do a get 7, then it's going to return a DAC value. And that DAC value corresponds to the voltage that that sensor is basically giving out. So you can connect any sensor or any motor or servo or anything and just send it these values, and it'll affect it, basically modulating the voltage or the pulse width ratios for you automatically and control the stuff. So if I wanted to write a program that just like once a second turned on a pump, turned it off, the way I would do it is I would just type read, say that's telling it read something, I'm going to write a program, Put 18100 to turn it on. Sleep 50. Each period by default set to 20 milliseconds because servos operate on 20 millisecond default, so 50 times 20 milliseconds, 1 second. Put 180. Sleep 50. Program's running. So I just programmed the beer machine. So you can see how fast it is, and that's texting. So you can just use this is just a Bluetooth terminal emulator, so you can just text it, or you can use this program like a graphical program where you just push buttons and it generates pieces of code and sends it down on the fly. So the cool thing is while that's running, you can also send it programs on top of programs. So it's actually a swarm operating system. So I can send it instructions. So now I'm sending it other instructions on the fly while it's running that other program. And so the reason that we develop it, that's the pump. That's the pump. So the way this thing actually works, just to give you, let me just stop it real quick. So I just gave it a blank program. The way this thing actually works is you have two pots. So you have one pot with grains, sits on one side, and you have another water pot over here. This can control the heat to the other pot. These pumps then will circulate the water through the grains at different temperatures to convert the grains into the sugars that you need for the beer. Pump it back in there, boil it, pump it back in there, cool it, and then you can plug this thing into your Coolitron fridge, and you can have temperature-controlled fermentation.
We actually have a beer brewing facility downstairs.
So this could be the perfect thing. I'm planning to do a Kickstarter on this for $99 for what you got here.
Cool.
So you got your own two pots, you got an Android app or an iPhone app, and basically you're watching the game while you're brewing. So that's really what this is about, is just enabling you to do other stuff, or you're making.
How can I find information about your little beer brewing thing?
So I can give you the link to the preview to the Kickstarter project, and then you can check it out.
Sweet.
And if you guys want to try one out, I can leave you one, and you can just be a beta tester.
Yeah, because the thing downstairs, it's almost been kind of abandoned.
Yeah.
We have a whole setup to brew beer, but
it takes a lot of time.
Gave up on it,
It takes a lot of time, right?
A lot, but now it's kind of like not active.
Does everybody know that Brew and Grow is around the corner?
There you go.
Yeah.
We have a store that sells
The equipment. So you got the malts and everything. So you could potentially even take this over to them and say, hey, you guys check it out and give us some of the beer.
You definitely should get a press release out to I don't know if there's like a Home Brewers Association of America or something like that.
Yeah.
Or some national whatever.
Yeah.
When you're going to get to that point for launching before you can launch your Kickstarter, just getting the word out.
Oh, absolutely. Absolutely. But anyways, so this is the second Kickstarter that we've done using this board, and really we're doing a whole series of Kickstarters, and we're trying to get other people to just show you how easy it is to implement something, because you don't have to be a programming genius to do what I just. Basically, me and this other university student that I'm working with named Sam. He's not here, but he's basically the one that did he does the mechanical and puts together all of the Kickstarter projects, and then if we get parts from China, he's Chinese. He basically gets those parts sourced for us like really cheap because he's Chinese. So that's kind of what we're doing. Is just kind of making this stuff easy for people to put together. And we got another example, which is a teaching drone, which is the first Kickstarter project that we did. So these power feds actually will drive wheelchairs. So I get electric wheelchairs off eBay for $50. Cut the wires, plug this thing in, boom, you got it.
Where are you from? Not Chicago.
Dallas. Yeah.
Oh.
I'm from Dallas. Yeah. It's. But it's on my blog, so if you want to see how to do it, I show you how to basically do all these things on the blog, and it's not complicated. It's not expensive. The launch pads are cheap. So that's pretty much the high level.
1 kilovolt's a lot. That's kind of crazy.
Well, not kilovolts. So the power feds. Yeah. So the power feds themselves are rated 60 volts up to 103 amps, which puts you roughly around 600 watts. But there's two of them, so you get 1.2 kilowatts of power. Now, if you try to drive that much current through here, the PCB is going to act like a fuse. So
for a very short amount of time.
Yeah, for a short amount of time, it'll naturally, keep bad things from happening.
It'll be a light bulb before it's fused.
That's right. And I've tested that. It's a feature. So,
I wonder, we have something here you're probably not familiar with, but it's called Power Racing Series. So with other hacker spaces around the country, it's going on for this like 5th year or something like that.
All those little cars.
So we take Power Wheels, they reinforce the frame, they do all sorts.
Those little cars actually.
But we soup them up. I'm wondering if that would be applicable to this.
You can put that straight in there. It'll drive.
Oh, okay.
Yeah.
Interesting. And that has Wi-Fi.
Then you can use basically your Android to steer it, with the accelerometer.
Right. So your mobile connectivity is both Android and iOS, right?
Yeah. So at the GitHub address, we have basically Tech Basic code, which runs in Tech Basic. It's basic on iOS. And then we have Android for Basic code that will run in Android for Basic.
Is that what's running on when you're typing in those commands? What sort of syntax is that?
So if you want to just use that's you can go to the App Store right now and download NBlue on iOS. It's just a Bluetooth Low Energy emulator.
Okay.
And it's the terminal emulator. So it's acting like a serial port over the wireless connection.
Okay. What would you do for Android?
There's also another one for Android. It's called BlueTerm.
Okay.
So you can download that, or if you go to GitHub, you can download the Android app that we wrote, which is pretty much a push button, or you can download the iOS app, which is push buttons.
Okay, so
there's actually 2 different apps for both Android and iOS you could use depending on whether, and they're open source. Everything, so you can modify one, make your own app.
Have you ever wrote open source or no?
Yes, everything's open source. It's all on the GitHub. So it's just GitHub.
What's your blog?
The blog is Rekam1.
Oh, I saw that.
Yeah, Rekam1.blogspot.
REKAM?
Yeah, it spells one maker backwards. So that's basically it.
Rekam1.
Yeah.
At
Rekam1.blogspot.com.
So this is the board that's in the beer.
That's the same board, yeah.
Okay.
Yeah, it's just sitting in there.
So this is it's a MSP430.
It's the same processor that's on this one.
So the same thing that's on the LaunchPad, but it also has a Bluetooth chip.
It's got a Bluetooth chip on the back.
On the back, okay.
Yep. And then it's also got the power FETs, and it's got voltage regulation that'll take it up to higher voltages. So if you wanted to run it off a 24-volt system.
Okay. So the
off 24 volt.
The Bluetooth chip on here is what you're connecting to with your phone or your iPad.
That's right.
And then that's talking to the MSP430.
That's on there.
Okay.
And that's what's actually controlling the signals to the pin, whether it's capturing data off the pin or pulsing data to the pins. And you can connect HS servos directly to those pins too. So it's got the ground 5-volt pulse.
Like hobby servos for an airplane?
9G servos.
Okay.
The $2 ones you get off eBay. You can connect 4 of them.
So, have you done other projects with using this like simple interface?
Yeah.
Okay.
So I've got stuff outside where I'm controlling sprinklers and doing stuff around the yard.
Right.
I've got a project where I'm doing kind of energy harvesting and basically distribution of power coming off wind generators and stuff like that.
Okay.
And I got a few projects. They're on the blog, and I'll walk you through the electrical, mechanical, and programming using the VM.
And it's all the hardware is also open source as well.
Yep.
And the LaunchPads too, right? They're all open source.
Yeah.
All open source hardware as well.
Yeah.
So you get the source code, the schematics, the layout, bill of materials,
that's
all
right.
that.
So if you wanted to take the design and tweak it, and actually we use, like on this board, we use Express PCB as well. So if you wanted to make some small modifications to the Express PCB files, then you could use that.
That's a CAD program?
It's just
a service for getting printed circuit boards made.
Yeah, it's just a real. It's like OshPark.
Right. Okay.
So it's just another cheap online PCB manufacturer.
Okay.
That will enable you to tweak the boards without having to do large runs. And these things, if you go through PCB Express, they cost you like, let's see, it's less than $10 per board to get manufactured. So you can get really small batches manufactured.
Anybody here use OshPark or Express PCB? Have you used OshPark at all?
I have used OshPark several times. Yeah.
You can basically you can upload your design file for a printed circuit board. I don't want to be on.
Okay.
You can upload your PCB design online, and that it'll actually price it out, and then you pay for it, and you get your boards back, free shipping in about 14 days.
Yeah.
10 to 14 days. to get a board. It's like
And you can expedite.
from artwork to board.
Yeah,
And,
you can expedite those things too if you pay a little more.
Yeah, what's the
and $5. It's like $5. I'm sorry.
what's the minimum run?
I actually ran some things where I wanted to experiment for how small I could make surface mount traces and such. So I was trying to test the limits. So I was making boards that cost about 30 cents a piece. I got 10 of those. It's like
There you go.
they don't quite have they charge $5 to $10 per square inch, I think.
Yeah,
And that's where you're only paying by the area you use.
yeah.
You're not. So there isn't
So
a
you're making
minimum.
small
There isn't a
boards like
minimum.
that?
There isn't a minimum price. So I was
That's
making
actually
something not
pretty-
much larger than surface mount components. And yeah,
Yeah, I mean, it's a good way to iterate on the board. Like, if you don't think you're going to get it right the first time, or you don't know, then it's not going to cost you that much.
How many times did it take to get? Is that the first try or
No,
no? Okay.
that's why we use Express pieces.
Right. So
We went
the
through like 50 iterations,
right.
but we did a lot of different parts on there. So that was different power supplies, different stuff, and then different configurations with the pins and stuff. So we found, okay, people want to connect this many servos typically, or they want to connect this many motors, they want this much power, this type of regulation. So there was a lot of experimenting.
Cool. Well, you had shown me earlier the Android app had a bunch of different buttons on it for, like, instead of typing in the commands, you could just hit
Right.
buttons.
That's this right here.
Right.
So basically what you've got there is the same language. It's all on a single screen. So you just change the pin that you want to reference. So instead of pin 7, if you wanted to talk to pin 8, and then you would hit, well, it's not connected right now, but
Oh, okay.
but basically if it's connected, then it just sends that command, and you see
Okay.
the return, and you can type up the programs. Literally, you can program the platform in less than 10 seconds.
So instead of having to type at all, you can just press those buttons
And
to.
Engineers are lazy.
and the Android app's also open source.
Yes. Yep. Everything's open. So it's written in Android for Basic, and the iOS is written in Tech Basic, and the Tech Basic.
So what is Android for base?
Android for Basic is basically it's a basic programming environment that makes it simple to write Android code, so you don't have to worry about knowing all the Java APIs and getting up the whole tool chain. You can actually just download and write the code quickly on your PC, and it's interpreted and then turned into an APK for you.
Oh.
Android for basic?
Android for Basic, yeah. Or Basic for Android, I'm sorry, I might be
The
just like...
letter 4 or number
4, yeah, 4.
Number
Number 4,
four?
yeah. It's either Android for Basic or Basic for Android. It's too late for me to remember everything. But Tech Basic then is the same thing. So Tech Basic, here's what it looks like, right? So Tech Basic, oh, everybody knows my code. All right, let's see.
Actually, I think your hand was in the way, so don't worry.
Here's Tech Basic, right? So Tech Basic, here's the source. Boom, you write it, you edit it here. You're ready to run it. Basically go to the graphics screen. This is
So you would type basic code on your iPad?
directly on the iPad or
Oh,
iPhone.
okay.
Yeah, there's nothing else except the device. And there's something similar, and that's basically the program that's running. And so you can take this project and then import it into Xcode, spit it out, run test flight, put it out on the App Store.
So this, you type a basic program and then it creates a iPhone or iPad app from it?
Yeah.
Okay.
Yeah, that's pretty much it. So basically, they got a set of APIs, and what's cool about Tech Basics is different from just other basic interpreters. It also includes the Bluetooth Low Energy stuff. So I can write apps that talk to Bluetooth Low Energy connected microcontrollers through the same app, because all that code's already there.
Cool.
So that's what makes it cool is you can write in the same environment the code that runs on your iPad or iPhone, as well as the code that will run on your microcontroller. So it's completely, so I'll literally be on the